Welcome to DT Plus. This is your single gateway for heat risk intelligence, everything in one place. It is developed by SenseNOAA team at the National Observatory of Athens, and it got awarded the most promising proposal in the second Innovation Challenge of the European Space Agency for Destination Earth. 1 year later, it is available on board Destination Earth platform with a partnership with ESA, ECMWF, and EUMETSAT. It is funded through a European project, CARMINE, which supports climate resilient development in metropolitan regions across Europe.
Here you will be able to see how to get started. So first, how to log in. There are two ways of logging in. One is to log in via the link of DT-HEAT, or you can use your Destination Earth account. So here in the login platform, you can click on this link and then you can log in using your credentials with Destination Earth. If you want to register with DT-HEAT directly without going via Destination Earth, you can click on register. It is a very simple registration process where you provide basically an email and your contacts, and then you will get a confirmation email from DT-HEAT. I'm going to log in using my Destination Earth platform EAM. So I'm going to enter my credentials. Now I'm going to log on using my credentials. What do you expect when you start your journey in DT-HEAT Plus? So first you have the home page where you have a selection of different cities. You have the different cities available here. Please be informed that we're talking here about metropolitan areas. So you will see some information about the metropolitan area of Athens, Prague, London, and Bucharest. And also you have clickable pictures here that you can click on, and then this takes you to the city of your interest. I'm going to start with the front runner for this development, that is the city of Athens, metropolitan city of Athens. And this takes me to the second tab that is called Now. So what do we expect to see in Now tab? So you see the date and time. This is the local time in the city of Athens now that we record this tutorial. And this is the temperature outside, that is the 34 degrees Celsius. This is the aggregated temperature for the whole Athens metropolitan area. Also, we have the relative humidity and the wind direction and speed, and also precipitation, which today, that is actually the beginning of a heat wave, is of course 0, whereas heat risk is extreme. What is most important here is these two boxes that say mortality relative risk. So why we have two boxes? We have two boxes because we have two models. One model is taking measurements from GFS, weather forecast, and the other model is taking measurements from ECMWF IFS NEMO model. So according to the predictions of GFS, the mortality relative risk due to heat today in Athens metropolitan area is increased by 38.7%, whereas based on the other model is 27.4%. On the right, you have very detailed information and also a reference of how these calculations are made. Further down, you see the so-called horizon chart. The horizon chart visualizes the trends for meteorological variables like, for example, the air temperature, the land surface temperature, the wind speed. But what you will see here is that we have these variables for hourly measurements from two models, the ones that I mentioned before, that is GFS and IFS NEMO. From the back is today, and then the next two peaks here are the values for tomorrow. The second one is again the aggregated value for tomorrow from the two different models here. You can also click on days, where here you have the daily average meteorological conditions from three models at the moment for Athens. This is GFS, IFS, NEMO, and also from the Academy of Athens that is providing specific details regarding Athens, but this is a local tailored development and deployment within CARMINE project. For the other cities, you will only find at the moment the predictions from the two models. Also, you have the maximum temperatures and wind, and also the minimum. The minimum is actually quite important for mortality risk due to heat. Now, if I move to the second tab, I can find more information about what is happening in the last 5 years in the city of interest. When you click on last 5 years tab, the first panel is a correlation matrix. The correlation matrix can be read in two ways. One is that it gives you the relative risk due to heat and how this risk is correlated with the environmental variables like the wind, the temperature, and all the different parameters extracted from this. But also you can see the clustered view. The data is the same, but it is restructured so that you will see groups of correlated, positively and negatively correlated variables. So it is easier to understand which are the variables that are relatively correlated with relative risk or negatively correlated with relative risk. For example, for Athens, this is relative humidity. In other cities, these correlations might be different. On the right, you will be able to find information about the different variables and how to read this plot. The second plot that you see is how the relative risk changes with the average air temperature for the metropolitan area of interest. In this case, we are showing Athens. So you see different curves, the red ones and also one black. And the black one is for all age groups. This is for the whole population. And the different red ones are the different age groups. Of course, as you would expect, the age group more than 85 years old, of course, has the highest relative risk. The red line that you see here is what is happening today. So what should we expect for today? This is where to find this information and also to see how today is compared with the last 5 years, with the values that we found in the last 5 years. I repeat that the x-axis is the average daily temperature, not the maximum. Again, on the right, you will see information about this plot, more information. Going now to the 5 years temperatures histogram. In the present plot, you have the mean average daily temperature for the last 5 years, and this is a histogram that gives you the cumulative percentages, and you see where we are today. So today, with 31 degrees of average temperature, we are in this percentile of average temperatures of the last 5 years. If I go to maximum, I see that this moves further down. And if I go to minimum, this moves quite high up, which means that the actual minimum temperature expected for today is actually quite extreme. The last tab you see is called restricted. If you land on this page, it says that access is restricted because this page is only visible for certain users because it gives you the heat-related mortality predictions. So either the city you are seeing does not have mortality predictions for the reason that this dataset is not yet available to the development team, or because you are not an authorized user to see this page. More details appear in the text, and if you think that your mandate as an organization allows you to see information like the actual heat-related mortality predictions for today, then please contact dtheat@noaa.gr. From the cities, which is actually the homepage, and next to the user account, you see the information tab that if you click on it, there is documentation about DT-Heat Plus, what it is, why it matters, and of course, how it works. So this will help you navigate easily through DT-Heat Plus.
So now we invite you to explore the platform DT-Heat Plus, make an account and enjoy all the different features. We're just at the beginning, so there is much more to come. We want to add more cities, more tools and features. Of course, we will also play around with solutions, especially nature-based solutions, and to see the impact that they have on mortality, especially large-scale NBS. We want to see what is going to happen in the future with different climate projections and much more. So stay tuned. We have a dedicated email address, dtheat@noaa.gr, and we expect your feedback and also your questions. Thank you very much for watching.